All right, guys, so about this time, you were probably sweating your upcoming stoichiometry test, right? Here it comes. So for our final tutorial installment, right, you guys should all have in your possession that stoichiometry practice test, okay? Which actually is just last year's test. So the test I gave to my students last year, this is that practice test, okay? And for this particular video, we're going to focus on number 2, number 4, going to the back, number 7, and then that very last question, number 11. So it's 2, number 4, number 7, and number 11. We're going to go through each of those. First one will be pretty quick, but this may take a while. But if you guys are sweating this test, hopefully this will nudge you in the right direction as you guys prepare for that, okay? Some tools to make sure you have in front of you are, of course, our ever handy periodic table with your list of polyatomic ions on the back, and then one of those calculators, because you guys, you should be trying to solve these problems along with me, all right? You're just kind of using my voice and my clarification for just that, clarification, right? We want to try to be able to do these independently, obviously, before the test, okay? So here goes. Start with number 2, right? Written up here on the board, it says, how many moles of iron oxide are needed to react completely with 1.2 moles of aluminum? So this is just the type of question to make sure you understand mole ratios as they're written in a balanced molecular equation, okay? So what we have here in this case is, if we read this reaction, right? We have 2 moles of aluminum plus 3 moles of iron oxide yields 3 moles of iron and 1 mole of aluminum oxide, right? That's how we need to kind of read those coefficients, big numbers in front of the compound. That's what we have to read that as, okay? And so, what we have to understand then is if we are trying to compare iron oxide to aluminum, all right? So we're actually just talking about our reactants in this case, okay? Aluminum and iron oxide, right? So if I have 1.2 moles of aluminum, right, how many moles of iron oxide are needed, right? And so what I have to do is I have to take this 2 and this 3, and I have to set that up as a ratio, all right? And the way I showed you guys to do that in class looks like this, all right? So how much aluminum do I actually have? I have 1.2 moles of aluminum, right? And so the nice thing about that unit of moles is it allows us to interchange one compound or element to another, all right? Because we already have our balanced equation, all right? If you didn't have a balanced equation, of course, you have to write the balanced equation before we could go forward, all right? But what this means is for every 2 moles of aluminum, I produce 3 moles of iron oxide, right? So it really doesn't matter how many moles of aluminum I actually have, right? In this case, I just need to know that however much I do have, I'm going to have a 3-to-2 ratio for iron oxide, right? Or 1.5 times as much iron oxide in moles, all right? That's why we have to convert to moles first, okay? So I have 1.2 moles of aluminum. So in 2 moles of aluminum, or with 2 moles of aluminum, I produce 3 moles of iron oxide, okay? That is what I'm actually accomplishing here, right? Is I'm taking the amount of aluminum I have in moles, right, and multiplying it by the ratio of aluminum to iron oxide, which is 2 to 3. Now, how do I know the 2 goes on bottom and 3 goes on top and not the other way around, okay? That's why we label things, right? So I'm starting with 1.2 moles of aluminum, right? So way back beginning of the year, if I have moles of aluminum on top in one step, I know that moles of aluminum needs to go on bottom in the next step, right? So whatever's on top here needs to go bottom next, right? Okay, so if moles of aluminum goes on bottom, that's why the 2 goes on bottom. And then 3 moles of iron oxide goes on top. Whatever I'm converting to ends up on top. That's that other little rule we talked about. Whatever I'm trying to figure out iron oxide. So iron oxide needs to go on top in this case. All right? So that cancels out my moles of aluminum. So if I go 1.2 times 3, enter, divided by 2 equals 1.8 moles FeO. And in that case, that will be my answer, because it's asking how many moles of iron oxide do I need in order to react completely with 1.2 moles of aluminum. I need 1.8 moles of iron oxide, which, as you may notice, is 1.5 times as much, right? 3 is 1.5 times 2. You can think of it that way, okay? So that's the fundamental principle. That's why I wanted to start with this one, is this is really the underlying logic behind everything we do, right? Then it's just a matter of converting inatom moles from that point. But this is the underlying principle that guides our entire stoichiometry process, is being able to understand this relationship that exists here. And it also works if you're going from a reactant to a product. It's the same logic, it's the same underlying principle. All right? But we have to put things in moles. Moles has to be that unit that we use, okay? Because that's the only way we can use this ratio, because it's a molecule per molecule basis. We can't measure individual molecules. They're way, way, way too small. So we use this term mole because that takes our molecule amount and brings it up to an amount we can actually measure with grams in the laboratory, okay? But it's the same ratio as if it was atom to atom or molecule to molecule or whatever, okay? But this is what underlies everything we're doing. It's this simple principle right here, okay? And then we convert into moles and we convert back out. That's why there's so many steps sometimes, okay? So let's move forward. All right, so number 4, a slightly longer problem, okay? So it says aluminum reacts with sulfuric acid to produce aluminum sulfate and hydrogen gas. The skeleton equation was actually given to you guys in this case, so I wrote that out for you for number 4, right? And so first thing is you are to balance the reaction, right? Then, once we have a balanced reaction, we want to do a calculation to figure out how many liters of hydrogen we need, or we're going to produce, if we begin with 25.0 grams of aluminum. Now, I needed to save space on my whiteboard, so I didn't write it out exactly the way it looks on your practice test. So that's why it's kind of abbreviated a little bit, okay? So, first things first, let's balance this bad boy, all right? So, here, I have 1 aluminum written over here. Here I've got 2. So let's maybe start there. Let's see what happens. I'll put a 2 here. Okay. Well, that balances out my aluminum, right? But I noticed with this Al2SO4, I've got 3 sulfates and just 1 here. So I'm going to try 3 there, right? Which, yes, of course, does throw off my hydrogen a little bit, but at least it gets my aluminums and my sulfates balanced, right? So that produces 6 hydrogens right here. I need to also have 6 there, but hydrogen gas, of course, is H2. So if I put a 3 here, I think that does it. That should balance us, okay? Now that's review, so I'm not going to spend too much time on that, just thinking out loud as we went, right? This is the part that we're actually, this is something we should know how to do, okay? Crying out loud, all right? But down here, we want to know how many liters of hydrogen gas would be formed, right? So how many liters? This is what I'm calculating. So this is my question mark, right? If I begin with 25 grams of aluminum, okay, 25.0. So that 0.0 is important for sig figs. I'm going to try to adjust this so we got a little more space to show that, okay? So what I have in this question is I want to figure out liters, right, of hydrogen gas if I'm starting with 25.0 grams of aluminum, right? Now, what do I have to do before I can use these ratios up here, right? I have to convert to, better say moles in that case, right? So the only way I can use this reaction to help me figure this out is to put the numbers that I have into moles, right? So what number am I given? I'm given 25 grams of aluminum, right? So I need to convert 25 grams of aluminum into X number of moles of aluminum, all right? And how do we go from grams to moles? We divide by molar mass, okay? So I'm going to erase that little question mark so I got space. I have 25 grams of aluminum, 25.0 grams, Al. Right? And if I go to my periodic table, I will find that aluminum has a molar mass of 26.98 grams, Al, and 1 mole of Al. Okay? Right, so 26.98 grams of aluminum per mole. Right, now I'm in moles of aluminum. Okay? And so what I'm doing is I'm starting with a certain number of moles of aluminum, right? My mole ratio of aluminum, and what am I trying to figure out? Hydrogen. So I need to compare aluminum to hydrogen. So my mole ratio in this case is 2 moles of aluminum to 3 moles of hydrogen. Now, I've got moles of aluminum on top here, so my moles of aluminum is going to go the bottom next step. 2 moles of aluminum to 3 moles of hydrogen. All right? So again, I convert it to moles of aluminum. Once I'm in moles, I can use my mole ratio to figure out for whatever element I'm trying to get. So in my question here, it says how many liters of hydrogen gas. So I need to compare aluminum to hydrogen, because hydrogen is what I'm trying to figure out. Now, I could also do a similar question where I figure out how much sulfuric acid I need, or how much aluminum sulfate I produce. I can do that too. This question is asking about hydrogen, so I'm comparing aluminum to hydrogen. Okay? So, now I'm in moles of hydrogen. What do I want my answer in? Liters, right? Can we go from moles to liters of a gas? Yeah, so with all these gas questions, of course, we're assuming STP, right? We'll do a gas law unit later where that's not always the case, but for now, right? So at STP, how many liters of gas do I have per mole? 22.4, right? So this says moles of H2, so I'm going to put 1 mole of H2 at the bottom and 22.4 liters H2 on top. Right? Now I can just go through and multiply. I'm going to go 25 times 3 times 22.4 equals, right? And go divided by 26.98 equals divided by 2 equals, right? And then I should get 31.1 liters of H2 as my answer. Okay? So again, we started with our balanced reaction. I gave you the skeleton equation. We balanced that first, and that balanced equation allows me to convert from one substance to another as long as I'm in that unit of moles, right? So once I knew my mole ratio from my balanced equation, I was then able to convert aluminum into moles first, right? Gotta get to moles first, right? Once I'm in moles, I looked at for my mole ratio from the equation. So I had aluminum, so I started with aluminum, so it goes bottom. I'm trying to figure out how much hydrogen I get. So I look at my hydrogen part of the equation. So aluminum on bottom, 2 moles of aluminum produces 3 moles of hydrogen, right? So there's our ratio, right, taken care of, right? And then what unit did I want my answer in? Liters. So I converted from moles of hydrogen back into liters with that magic 22.4 number. And when I do my calculation, 3 sig figs there, I should get 31.1 liters of hydrogen gas. Okay? All right, let's move on to the next one here. Change whiteboard. All right, so we're going to move on to number 7, I believe it is, right? It looks like my number 7 is covered up, so I'm going to say this is number 7, of course, okay? So, number 7, from the second page, bottom of the second page there. All right, and again, I sort of abbreviated the question a little bit, save space and time for me, okay? It's all about me, right? So anyways, so in this case, number 7, I have 25.3 grams of potassium, right, is added to 43.2 grams of aqueous aluminum sulfate. Calculate the amount of aluminum produced in the reaction, right? So this is going to be one of those questions where I have two different reactants with two different amounts, right? And those amounts are in grams, all right? And I also notice I don't give you the balanced molecular equation, right? So we got a lot we got to do to solve this problem. First, we have to write and balance the reaction, okay? Then we got to convert both of our reactants into moles, all right? Now, when I give you two different amounts of the two reactants, right, we have to figure out which of those is going to actually predict the amount of product. So this is a limiting reactant type question. So we got to write and balance the reaction. I got to convert my two reactants into moles. I got to figure out which one of those is limiting. Then I can solve the problem. So we got lots to do here, right? It's going to be one of those long questions. You guys love those, I know. Okay, so where to start? I think it's always good to start by writing a balanced molecular equation. Okay, so we'll go there. So what is reacting? I'm reacting potassium with aluminum sulfate. All right, now can I write the formula for that? Of course I can. All right, so let's go through. So potassium, which is a K, right? So potassium is being added to aluminum sulfate. So potassium, of course, is a +1 when it's an ion. Aluminum's +3. Sulfate's a -2. Sulfate, of course, is found on the back of that. Well, most of you guys have that on the back of your periodic table, that polyatomic ion sheet, right? So potassium, so I'm going to have 2 aluminums, 3 sulfates, so it's going to be Al2SO4 3. All right, so in this reaction, potassium is a plus. Plus always replaces the plus, right? So potassium and aluminum will switch places. Okay, so we're going to produce potassium sulfate. All right, so since potassium's a +1 and sulfate's a -2, right? So +1, I'll write the +1 here so we can see it better, right? So I'm going to have 1 sulfate and 2 potassiums. Okay, so that's that formula. So K2SO4 plus aluminum. All right, now I got to balance this guy, right? So first of all, what do I notice about right here? I have 2 aluminums, right? Over on this side, I have just 1, so I could probably put a 2 there pretty safely for now, okay? Now, also right here, I have 3 sulfate ions, right, attached to those 2 aluminums. Over here, I just have 1, all right? So where can I balance that out? I have to put a coefficient in front of the whole thing. Yes, you can't just add a subscript wherever you feel like. You can't do that, okay? We balance with coefficients, right? So I'm gonna put a 3 there, so that balances out my sulfates. My aluminum's balanced, but now I have 3 times 2, 6 potassiums. I need 6 over here. Boom. Now I'm balanced. Okay, that part's done. So we're going to look for a 6-to-1 ratio in our reactants in terms of moles. Okay, so I have grams of potassium and I have grams of aluminum sulfate. I need to convert those 2 numbers to what? Moles. All right, so let's do that. All right, so in this case, I have, doesn't matter which one we do first, I'll just do potassium first since it's written first in my equation. I have 25.3 grams of potassium. All right, now, how many grams of potassium make a mole? Where do I find that information? I find it on the periodic table. So the molar mass of potassium is 39.10 grams of potassium and 1 mole potassium. All right, and that is going to give me 0.647 moles of potassium. Now, with these limiting reactant questions, you're going to be putting so gosh darn many numbers up here. You better label them, okay? And when I grade your test, if you're not labeling your stuff, I'm going to get pissed. All right, label your stuff, okay? How much longer does it take to label moles of potassium? Just do that. Don't be lazy. Laziness is unbecoming. Okay? So on a test, for crying out loud, tests are important. Label your numbers, please. All right. All right. All right. Okay? So I got 0.647 moles of potassium. All right? Now I'm going to take my other reactant, which is aluminum sulfate. Right? So aluminum sulfate, I have 43.2 grams of it. Oops, that's a little bit sloppy. All right, so I need to find the mass of 2 aluminums plus 3 sulfurs plus 12 oxygens in that case, okay? And when I add that tally, it's a big number, it's 342.17 grams of aluminum sulfate. 1 mole aluminum sulfate. All right, and that is going to give me 0.126 moles of aluminum sulfate. Okay, so I did what Ms. Hudebrink just told me. I took my known quantities of reactants, I converted them both to moles. So how do I figure out which one is limiting? How can I figure that out? Okay, so this is where the mole ratio comes in, right? So again, I've got my quantities in moles. So now I can use these two numbers and compare to what I see up here, right? So these are my 2 reactants, potassium and aluminum sulfate. Hey, look at that, it's labeled, so I know which is which. All right, so does this ratio right here match that, or is one of them not quite enough, or is one, there's just a little too much of it, some excess of it? All right, so those of you guys who are pretty good at doing math in your head, you can probably answer this just by looking. I need 6 times as much potassium as I have of aluminum sulfate in terms of moles, right? I don't quite have that much. If I was to multiply this number by 6, I would end up with a number bigger than that. But let's just do that off to the side. Let's see what happens. Or if I was to divide this by 6, I would end up with a smaller number than that. All right, but let's do it off to the side just so you can see my logic here. Okay, so I just usually like to pick the first one because it makes sense to me, right? Do things in order. So when I'm trying to figure out which one's limiting, I pick one of my 2 reactants, and it doesn't matter which one, as long as whatever you end up with your answer, you compare to the correct number. All right, which is why we label things. Okay, so what we need to picture here is this is the amounts I have. Right? So when it comes down to doing or figuring out how much aluminum I get, I have to start with how much I have, but I don't know which one of these 2 numbers to start with. Okay? Yeah, well, some of you guys may know that just by looking. But let's go ahead and figure out which one I should start with. We always start with the limiting one, so let's figure out which one's limiting. All right? So if I have 0.647 moles of potassium, right? What I can do is I can just multiply by my mole ratio to figure out how much aluminum sulfate I need to use all that up. Does that make sense? Okay, so if I have this much potassium, well, how much aluminum sulfate do I need in moles to use all that up? All right, so I need 1/6 the amount, right? So if I have this much in 6 moles of potassium, I only need 1 mole of aluminum sulfate. All right, so I'm taking my initial amount of potassium in moles and dividing it by 6 because I have a 6-to-1 ratio there, right? Because since moles of potassium is on top here, moles of potassium goes on bottom in the next step, and 6 goes with the potassium. Okay, so when I go 0.647 divided by 6, I should get equals 0.108 moles of aluminum sulfate. All right, so what did I just calculate? I calculated the theoretical amount of aluminum sulfate I would need to use all of this up. All right, so I'm going to label this need, or needed maybe. Okay, so This is aluminum sulfate. I need to compare it to my other number for aluminum sulfate. All right, and so I have how much I have and how much I need. I need to compare those two numbers. I have 0.126 moles of aluminum sulfate. I need 0.108. So I have more aluminum sulfate than I need. When you have more of something than you need, that makes it excess. All right, so if aluminum sulfate is excess, that means potassium is limiting. All right, so my potassium in this case is the limiting reactant. And I know that because I figured out how much potassium I have in moles. I figured out how much aluminum sulfate I have in moles. Then I used how many moles of potassium I have to figure out how many moles of aluminum sulfate I need. Okay? So because this is aluminum sulfate, I need to compare it to the other number I have for aluminum sulfate. How much aluminum sulfate do I have? 0.126 moles. How much aluminum sulfate do I actually need? 0.108 moles. I have more aluminum sulfate than I need. When you have more of something than you need, it is excess. This is excess. If this is excess, this one is limiting. All right? Now, guess what? I can actually start this thinking problem. I know how much potassium I have, and I know I need to use that number to figure out how much aluminum I get, right? Because that just means I'm going to have some aluminum sulfate left over after I use up all the potassium, okay? So what I'm going to do at this point is I'm going to get to my stoichiometry problem, right? What I'm trying to figure out is how much aluminum will I produce theoretically if I do this reaction perfectly, okay? So which number do I use? The limiting number, right? So I have 0.647 moles of potassium, right? What am I trying to figure out? How much aluminum I have. So I'm going to compare 6 moles of potassium produces 2 moles of aluminum. All right, so again, I'm starting with moles of potassium because it's my limiting reactant. So I know moles of potassium needs to go bottom, and the 6 goes with potassium, right? I'm trying to figure out aluminum, right? So I'm going to go from potassium to what I'm trying to figure out, aluminum. What I'm trying to figure out goes on top. So it's a 6-to-2 ratio. So now I'm in moles of aluminum, right? Now, the question is the amount of aluminum produced, right? So, I guess, theoretically, moles is the amount. So could you stop this question right here and just figure out moles of aluminum? I suppose. On your test, I'm going to try to be more careful or specific about what I actually want you to put for your answer. So let's go ahead and put this in grams because, again, in a lab, how can you tell if you actually get X number of moles of aluminum? You have to find its mass in grams anyways, so you might as well figure out your answer in grams. That's something we can actually measure in a lab. Okay? So let's go that one more step. 1 mole of aluminum. All right, we have 26.98 grams of aluminum. Okay, so when I do that calculation, I should end up with 2.91 grams of aluminum. That 9 looks horrible. And shazam, 2.91 grams of aluminum metal. There we go. Okay? All right, so